very good food. And I'm the first speaker after a very nice meal, so I will try to make sure that everybody is awake. So I will give oops, I have to be careful. I will give an introduction about Subcommittee 41 in the different strategic direction. Does it does work? So first, give a context, the context of GTC1, Standardization, and ISO and IEC. Talk about briefly the nature of the Internet of Things, which is, again, I think very pertinent. Also, the convergence of IT and OT and the industrial Internet of Things. Succinctly, introduce Digital Twin. There'll be a presentation that is much more detailed later, and then talk about the strategic approach, our status, and our future direction. So, what is the Internet of Things? Again, it's a summary, but Internet of Things standardization is done within the Joint Technical Committee of ISO and IEC. This is what's meant by GTC1, the first technical committee. It was created in 1987, if my memory is right. And it was created with a mandate to standardize IT technologies, information technology, and also consolidate existing work. There was a lot of work that was done already in the ISO and the IEC. So when you see those numbers, you can see that the higher the number, usually the latest the committee was created. Usually, it's a fact, and 41 was created a good 7 years ago. But, here it is. But it was not created out of nothing. Standardization work in the area had already been initiated, in some case for quite a while, in GTC1, in working groups. So there was a working group on sensor network and another one later on IoT. And then the decision was taken to create, in 2016, a subcommittee, a larger organization. It was also created as a system integration entity. And I'll expand a bit more about why and what it means. So why a system integration entity? You can see there again the mandate. It's because the Internet of Things, if you can look at the definition of the IoT, talking about an infrastructure of interconnected entities that, again, will provide, again, process information and react to this information from the physical and virtual world. So it's not a technology, it is a system concept that integrates many technologies. And those technologies are very varied. There's a lot of them. We're talking about Internet of Things, so network, not the Internet, a network of things. We're talking about, from a computing point of view, a distributed computing architecture that can be simple or more complex. I'll talk more about that. And we're talking about also data-driven system. The key, again, the value that you try to exploit in IoT system is the data. Data that has to come, some of it, from sensors. And the most important is, again, IoT system are a key enabler of smart everything. Smart everything. So smart everything mean, again, farming, smart manufacturing, etc. Now, this is a concept diagram that I'm using. Look a bit old, has been retouched, but it does illustrate typical architecture of, again, IoT system. Distributed computing means that you have computing resource in the cloud, on the things, and in some case, when it's required, you will have it at the edge of the network. So we're talking there not only about the concept of using cloud computing, but you have also at the edge of the network, near the data, the source of the data, edge computing or fog node also. And at the extreme edge, you will see the expression miscomputing, or when you have interaction between the things, swarm computing. So I won't go into detail there. Why, again, and those, the choice of the architecture is dictated, again, by the requirements and the nature of the system. So getting the software closer to the source may be because you need to have some latency requirement, you need to have a fast processing and deal with large amount of data, or it could be because you want to have a more resilient system also. The things themselves, even sensors have intelligence. So we're talking about, the things themselves can interact between at their level. At the edge, you may have another network, and you have also, again, the main internet, if I can say, that connect to usually to the cloud and the large processing center there. And at each of those layers, you may use different networking technology. Excuse me, there's a latency. Sensors. Sensors are key to IoT system. And they can measure the physical world, they can measure a lot of parameters of the physical world, and they can do it in a very different fashion also. So, again, SC41 does not standardize sensors. And what we have coming out of those sensors is data. A lot of data that at the application level can be combined with data from other sources and need to be processed to extract the value. Now, another phenomenon that is important strategically is what we call the convergence of IT and OT. Essentially, IT refer normally to data computing, data processing, traditional way, while OT, operational technology, refer again to the industrial system that monitor event and react to it, that you'll find in factories. And there, those systems will not only have data coming from the physical world, but they will also be able to control, change the state of the physical world. And this is where you have actuators that are coming into play. Actuators that can be controlled by human or machine. And essentially, the world of industrial automation, if you go back to the 1990s, was a different solitude, if I can say, from the world of IT. You had the world of all the computer scientists, data processing person, which they own companies and consultancy. And then you had another world more tied up to the industrial engineering, which is, as you know, a mix of electrical, mechanical engineering. And the phenomenon that we saw in the last 20 years is the convergence of both those worlds, the integration of both those worlds. And this is reflected not only from a discipline point of view. I mean, I have colleagues that are now using IT not only to do some computation, but designing systems that are in industrial, construction engineering, etc. But also, you can see that on the industrial also point of view area. Now, the convergence of both of those worlds is what we call the industrial Internet of Things. From a standardization point of view, the world of GTC1 traditionally was the IT, as you can see up there, and the Does it work? No. And then all those industrial control standards were standardized in ICT 65. So what we have now is the convergence of both those worlds. And again, convergence means leverage, means also a lot of, it's opening the door to a lot of possibilities, new application, but at the same time, a lot of other issues. So nowadays, the moment you go into the world of the industrial Internet of Things, you have to think about, for instance, cybersecurity. So smart everything, everywhere. This is what IoT brings, but again, as I mentioned, IoT being a system concept. Digital twin. A few years ago, the scope of SC41 was widened to include digital twin. Now, what are digital twin? And essentially, you have the definition here, but we're talking there about a digital representation, fundamentally, of a physical entity. This is what it is. So a digital twin is software. It's software, but it's also more than a static representation. It is incorporate models, different models. When you want to simulate the real world, you may have to use different modeling technologies. The digital twin typically will be fed some data. They can be used in a design mode, but one of the interesting application is the operational mode. And now we talk about mirroring the real world, which means there is synchronization. So essentially, a digital twin will analyze, explore the data, use knowledge to model it, and you can use after a digital twin not only to have nice 3D representation of your environment with the interface and the status, but also to do some projection in time with the model. You have, and this is the value added, it's one layer higher than a simple analytic system. And those what-if analysis can bring a lot of value. And I will talk more about that. There'll be a presentation. So data is coming from sensor, but can come from other source. There's the concept of virtual sensor, where you can aggregate data from sensor, or you can have data coming from other state machine. Now, what's particular and common between digital twin and the IoT is that it is very horizontal. It's touching a lot of different areas. So digital twin can be used to model, to mirror a bridge. Or at the other extreme, there are people building digital twin for the planet and ocean. And in between, you have a program in Europe, and there may be others, to build digital twins of humans that can be used to do some preventive medicine and personalized medicine at different level. So many applications, many areas. Now, I was mentioning those technologies that are used, and they are a lot. You have the sensor, the actuator, and there's many committees in the IEC mostly that are developing standard for sensor. You need to have the expertise. Again, because a sensor, again, is when you have a sensor, solid state or others, you're exploiting physical or chemical phenomena. Cloud computing, edge computing, big data, large amount of data in some IoT system, AI, artificial intelligence that can be integrated in a digital twin also as part of the model, etc. Security issues are coming in, as I mentioned. And these systems must be engineered. So I mentioned horizontality, but in the case of SC41, and this is why we are a system committee, IoT system integrate a lot of different technologies, and those technologies are standardized by other entity other subcommittee in ISO, the IEC, and GTC1. On the other hand, the user of our standards are mostly people that are in the other sector than IT, application engineers that will use our standard to build system, to build smart farms, to build, again, a smart greenhouse with a digital twin, etc. So our nature is we're horizontal, but double horizontality from a technology point of view and also application point of view. So the strategic approach, again, that come out of that is that we must develop foundational standard so that, again, that can be used by all those different sectors. And those standards itself will refer to other standards that are being developed in those different technology. We need to understand how our customer, our stakeholder, and this is why there was a lot of work on defining use case for IoT and digital twin before we can build those foundational standards. And also, there are areas where we don't have necessarily people to talk to, or there may be too many people. So it's good to have an incubator group where some application-oriented standards may come in. Now, a way to illustrate, again, the way our standard can be used is in this diagram where you see at the horizontal, the bottom layer, IT technologies, and you have after that at the upper layer, and it's not a perfect, I mean, there's probably more arrows to be added and could be changed. It's only conceptual. All those different sectors, and you can see the word smart, that's why we say smart everywhere, that appear in many of those places. And the whole idea is that those horizontal standards can be used by the application engineer, the system engineer building those applications. So this means also that there's a need for coordination, there's a need to work in partnership with many other standardization organizations. And this reflects in our structure. Again, you can see that we have joint working group, we have liaison groups to be able to do this coordination. And we have a few working groups that are elaborating our standards, foundational standard in IoT, standard in digital twin, interoperability standard, and it's very important also, and then the group on IoT application, which is, in a sense, the incubator I was talking about. So I won't go to the detail, but you can see we have many standards that have been published already. We have very productive people in SC41 that are also very open and also a nice environment to build consensus that is necessary to publish those standards. And we have also many projects at different stages. What you see, PWI, these are simply slots saying that we intend to do a project in this area, and we are exploring those areas. So future direction, in a sense, is we need to continue to do what we're doing. Some of our foundational standards are already at their second iteration. It's a new area and it's normal. Digital twin is a bit behind. Work started not a long time ago, but now there's already 2 standards that have been published in the digital twin area, and we should have a good set of foundational standards within the next 2 years. And also, we do need to move on and continue in our cooperation, especially, I mentioned the IT and OT convergence, so it's important for us to work with the industrial automation people. And I think I'll finish there. Thank you very much for your attention.